In this video, we are continuing section 6.4 on solving trig equations, and we'll do an example where we solve a trig equation using a trig identity. So the example says we have cosine to the fourth of x minus sine to the fourth of x equals 1/2. And it's specifying that x needs to be a value between 0 and 2 pi. Okay, so how do we get started with this? Well, we have these two fourth powers here that we're subtracting. So what I want to notice is that I could think of these as perfect squares. I have something squared minus something squared, and then this equals 1/2. So what would go in the first parentheses is a cosine squared x, because if I square the cosine squared, the powers would multiply and I'd get cosine to the fourth. And in the second parentheses, we have sine squared x. Okay, because now I have a difference of squares. So I can factor my difference of squares. So that'll give me something minus something, and then something plus something equals 1/2. And within the parentheses, we'll get the first term, cosine squared x, and then minus the second term, sine squared x. And in the second parentheses, we'll get cosine squared x plus sine squared x. And this is really nice because the thing in the second parentheses, cosine squared plus sine squared x, well, that just equals 1. That just equals 1. So that's going to leave us with, it's leaving us with cosine squared x minus sine squared x equals 1/2. Okay. So you might think, well, difference of squares was great, and it simplified the equation because now instead of having fourth powers, I just have squares. If we try it again, we kind of get stuck. We'd get cosine x minus sine x and cosine x plus sine x, but neither one of those we can really simplify in the same way we did this. Okay, so what can we do now? So my tip is, if you see both sine x and cosine x in your equation, and at least one of them is squared, then try using the identity cosine squared x plus sine squared x equals 1. So we're going to actually use that again by isolating one of the variables. So it doesn't really matter which one we isolate. But let's say I were to isolate sine squared. Sine squared x equals, if I move cosine squared over, 1 minus cosine squared x. And now I'm going to use that to sub in to our equation. So let's sub in. So we'll get that cosine squared x at the front, cosine squared x, and then we'll get minus, and I'm going to sub in for sine squared, because sine squared equals 1 minus cosine squared. So it's important to have this parentheses around it, because this negative sign in front needs to apply to all of the terms in this. Okay, and this equals 1/2 on the other side. So now I can distribute that negative sign. So that'll give me a plus cosine squared popping out. So overall, that'll give me 2 cosine squared x. We'll also have a minus 1 and equals 1/2. And then let's try to isolate my trig function. What's really nice about this is now I don't have 2 trig functions anymore. So subbing in that identity let me get rid of one of the trig functions. So if I rearrange this, we get 2 cosine squared x. If I move the 1 over, I get 3/2. And then I divide the 2, and we get cosine squared x equals 3/4. Okay, so now I can square root both sides. So square rooting, I get cosine x equals, well, when I square root both sides, I got to remember I got a plus or minus, and I'll get plus or minus root 3/4, which I can simplify. So this gives me either, so I'll get square root of the top, which is root 3. Square root of 4 on the bottom is 2. So either I'm getting that, or I'm getting negative root 3/2. So my cosine x either equals root 3/2 or negative root 3/2. And now this is where the unit circle will help me. So from this first value, the root 3/2, we will get 2 answers. So we may need to refer to our unit circle here, or if we remember our unit circle. Well, this will give us x equals pi over 6, as well as 11 pi over 6. We get 2 answers from that. And then when cosine equals this negative root 3 over 2. We also get two answers. And those answers are 5 pi over 6 and 7 pi over 6. Okay, and we don't need to do that plus 2 pi k thing here, because remember, my x is between 0 and 2 pi, which means I'm only going around the unit circle one time. So these are our final answers.